Good afternoon, everyone. It's a great pleasure to see you participating this IPv6 Deployment SIG session. I'm the moderator of this session. My name is Yongyu Lin. I'm serving in National Communications Commission in Taiwan. And the charter of the IPv6 Deployment SIG is to share information and experience and best practice and measurement and statistics on IPv6 deployment, and to review technical and security and engineering issues related to IPv6. And in this session, we have 3 speakers. The first one is Mr. Phan Thian Hui. He is Manager of Technology Division VNPT from Vietnam. His main responsibilities are designing and planning VNPT's mass area network and IP core network. And he will present IPv6 deployment in Vietnam. Please welcome our first speaker, Mr. Phan Thian Hui. Mr. Phan, you have the floor.
Good afternoon, ladies and gentlemen. Now I will start my presentation. My name is Phan Thian Hui from VNPT Group of Vietnam. Now today, my presentation, I will introduce some of our experience in IPv6 implementation in our network from 2000 until now. And my presentation today have 4 parts. Firstly, I will give you some brief introduction about my company. The second is our plan to deploy IPv6 in our network. The third topic is our current result. We have deployed the IPv6 in network until now. And the last topic are some technical issues we had to face, and we had passed it. Now I will move to the first section. Our company is one of the largest telecommunication operator in Vietnam. We providing both fixed service network and mobile service. In fixed service, we provide fixed phone and internet service. For example, fiber optical network. We also provide IPTV and VPN service. In mobile service, we provided 2G, 3G, 4G service. And last year, we had trial 5G combo show. And maybe in the next year, we will officially launch the 5G service. And in Vietnam Telecom communication market share, we are the largest fixed broadband service. And in the mobile service, we are the second largest in Vietnam. And that's some brief introduction about my company. And now we will move to the main topic of my presentation today. I will share you some information about our plan and our steps. We have deployed IPv6 from 2000 until now. From early 2000s and to 2011, we have prepared the plan very early. From 2000, we have performed some activities on IPv6. For example, we organized some technical group on researching about IPv6, and the IPv6 application can be suitable for my service and my network. In that time, we also implemented IPv6 child in our lab because we have to prepare very carefully the IPv6 child to get all the technical issue we have. Maybe we have to face and prepare the best practice for it. We also checking the IPv6 compatibility of our existing networks device. We also working with the network vendors and many network operators who has some experience in implementing IPv6 to choose the most suitable model between the many IPv6 model. As you know, at that time, there are many IPv6 model. For example, dual stack, SIG-RD, dual stack lite, and at that time, no model was mature enough. So we have to discuss very much to choose the best model, the most suitable model for our network. At that time, to research and to child, we also providing some IPv6 disline internet for a few customers to get the experience. So in 2011, we built our plan from 2011 to 2020, following our national IPv6 plan. From 2011, our government released a national IPv6 plan. It had three phases from 2011 until 2020. The first phase is preparation. The second phase was start phase, and the last phase was the transformation from IPv6 to from IPv4 to IPv6, and accordingly to the national IPv6 plan, we built our own plan. Our plan have 4 phases. We prepare for IPv6 from the 2012 until 2013, and from 2014 and 2015 we make the child phase. From 2016 until 2018, we get the transformation phase, and the last phase complete. The reason why we divide in 4 phases, because in our experience, we knew that to deploy IPv6 smoothly, we have prepare step by step, and we have to do everything very carefully, because if we deploy the IPv6 not so smoothly, it may be impact to our existing service and our existing customer. It's very dangerous for us to prepare the service to the customer. And from 2011 to 2014, we prepare to implement IPv6 widely. We make the network reviewing to ensure that end-to-end IPv6 service can work. We review all of our network, includes both fixed network and mobile network. At that time, after reviewing our existing network, we realize that our network can deploy IPv6 quite easy. So we implement the IPv6 child. Firstly, child for the fiber internet service, and the second we made the child for the 4G service. And after the child, we realized that we realized that dual stack model was the most suitable for us, because it was more effective than other models. The next section in the technical issue, I will explain more detail about that. From 2014 until now, we officially launched IPv6 for fiber internet users. From May of 2018, we officially launched IPv6 for 4G users. And now we have a very good result about the IPv6 deployment to the customers. Now we implemented IPv6 for all cities and provinces in Vietnam. We have 60 cities and 63 cities and provinces in Vietnam, and now we cover all our national network. We can provide IPv6 service for all fiber service and for all our mobile service. We enabling IPv6 on all our peering connection, and we activating IPv6 on whole our transport network. And now all of my network can provide IPv6 to all customers who have the demand. And now we have nearly 6 million fiber subscribers and 5 million mobile subscribers using IPv6. Now we have on 6 million fiber subscribers. So the number of 6 million fiber subscriber active IPv6 is all of our fixed customer. But we have nearly 30 million mobile subscribers, but now we have only 5 million mobile subscriber active IPv6 because you know that the issue of the mobile handset is quite different with the fixed network, because in the fixed network we build our CPE, we build our firmware, so we active IPv6 default in the fixed CPE, so every customer can use IPv6 at the beginning of the service, but the mobile handset is quite different because we didn't manufacture the handset. There are many mobile handset vendor, for example, Apple, Samsung, Oppo, Huawei, and many others. So we cannot guarantee about the firmware of the mobile handsets. And now the mobile handset not active IPv6 by default. It's still active IPv4 by default. And if the users want to use IPv6, the user must active IPv6 in the APN setting of the mobile handset manually. So that is the difficulties of the deploying IPv6 for mobile subscriber. And the next section, I will I will explain more detail about our technical issue. You know that in the network, in our existing network, we still use IPv4. So if we deploy, for example, the SIG ID or dual stack lines, we have changed almost of our network router, and we have to change our service model. So it's very difficult. So so after the trial, the dual stack model, we think that the dual stack is the most suitable model for our network, and I think it will suitable for other service provider, because the dual stack will impact smaller to the existing network, and the IPv4 users will not be impact the IPv4 service when is running normally, not impact. But to deploy the dual stack model, we have some issue have to guarantee. Firstly, the network node have supporting both IPv6 and IPv4, and the network node must have the good performance for both IPv4 and IPv6, because you know that when we turn on the IPv6 on the router performance will increase very much. The CPU and the RAM will increase very much. So to get the good performance for both IPv6 and IPv4 service at the same time, the network nodes must be I think that and the network node must be quite the, for example, must have quite good performance to guarantee for the both service. And the most important thing is that the CPE and the mobile handsets, they must support IPv6, because you know that there are many CPE handset manufacturers in the world, and there are many kinds of handsets. So the most important is that the mobile handset manufacturer must build the firmware supports IPv6, and to increase the IPv6 user, I think that they should default active IPv6 in the firmware, because if you see the APN setting in the mobile phone, you will see that now the mobile firmware now still active IPv4 by default. If you want to use IPv6, you have to manually active by the setting. So that is the thing that impact on the IPv6 users. So if the mobile handset manufacturer active IPv6 or dual stack default in the firmware, I think that the number of IPv6 subscriber will increase very much. So that's all of my presentation today. So if you have any question, please feel free to ask me. Thank you very much.
Thank you, Mr. Fan Jianhui.
Yes.
Is there any question for Mr. Fan? Okay. The second speaker is Mr. Geoff Houston. He is the chief scientist at the Asia Pacific Network Information Center, where he undertakes research on topics associated with internet infrastructure, IP technologies, and address distribution policies. And he is widely regarded as the preeminent researcher on IPv4 exhaustion. And he is routinely referenced by international agencies and frequently quoted by the ICT media. And he will give us the presentation entitled IPv6 Deployment. Geoff, the floor is yours.
Thank you very much for that, and good evening all, or good afternoon where you are probably. It is a pleasure to join you. Yes, this afternoon or this evening, I'd like to talk about IPv6 deployment, and I'll spend a bit of time sort of answering a few of these questions that I think are on everyone's mind. Where is it actually being deployed today? Where is it widely deployed, and where are the most active areas of V6 growth? And as we sort of enter the second year of COVID-19 and the disruptions with this virus all over the planet, it's actually interesting to ask if our plans and deployment for IPv6 have been disrupted in any way because of all these lockdown measures and so on that have been happening over the last year, actually. So to start with, let's sort of take a big picture and then look at some maps. This is a plot of the percentage of users of the entire internet who can use V6. Now, the bottom scale is in years, 2014, 2015, 16, 17, and so on. And I've marked out the previous full years, 2019 and 2020. And this is the percentage of users, 0%, 5%, and somewhere between 25 and 30% of users. Don't forget, the internet has approximately 4.4 billion users. So when we're talking about over 25% of users can use V6, we are talking in excess of 1 billion people these days. Very big numbers. I also look at the difference between preferred and capable, because having two stacks working on your device doesn't necessarily mean you're going to prefer to use V6. You might, for example, use V4. And so capable says, if all I can use is 6, can I use it? Preferred says, if I have a choice, do I prefer V6? So some subtle differences between the two. Let's have a look at the world map though. If red is nothing at all, and green is everyone can do 6, at the start of January 2019, the bits that were in the middle were the United States, Germany, India, and some scattered amounts of Southeast and Southern Asia, and Brazil was slightly orange, but there was very little green. Move that forward by 12 months, and deployment in India sort of started to take even more momentum. And you also notice other countries, particularly in Asia, but of course France and Finland and the United Kingdom made some moves. And most recently, a couple of months ago, January 2021, the first of the countries to go more definitely green, India, has certainly made moves here. Let's focus on Asia for a second and actually have a look in there at the various countries. And let's have a look at Southeast Asia. And so Vietnam, we are watching you. It seems that the V6 deployment program really took off across 2018. And it sort of moved from less than 10% of the population of users in Vietnam at the start of 2018. And by the end of that year, it was up around 25%, moving up to 35%. Over the last 2 years, it's been more or less stable, and the growth from 35 up to 45% has been more moderate. But the big impetus in Vietnam was 2017 and 2018, which really made the moves here. And now it's almost infill rather than dramatic moves. Myanmar, more recently, moved in mid-2019, and they're currently up at around 20% of users in Myanmar. Thailand, slightly earlier adopter, 2016, 2017, but here it hasn't plateaued yet, and 2020 was still a fair amount of strong growth. Malaysia has been doing this for many years, and again, steady, constant growth. And right now they're up over 50% of their users. The Philippines actually only did it a year ago, almost precisely a year ago, in late April, moved from 4% up to 12% in a single move. And so some of these providers simply just turned it on at some point after testing. In Western Asia and the Middle East, the big move is actually in Saudi Arabia, where over the last 18 months or so, there have been moves by the big three to go all V6. One suspects that the regulator got involved and there's a certain amount of collective action. United Arab Emirates actually pulled back a bit in 2020. I'm not sure why, but again, up at 30%, it's quite good. And Israel, finally, after many years of testing, moved in 2020. In Southeast Asia, the dramatic story is India. They're now up around 70% of all users of V6 capable, which is an astonishing achievement when you consider how many users that actually means, because India has a huge amount of users. The bulk of the work was done originally by Bharti Airtel back in 2017, and a number of others followed suit very, very quickly. But even in 2020, the numbers continue to rise. Sri Lanka, slightly slower, but very definite activity at the end of the year and the start of this year. And Nepal, again, another, it took a while, but then again, very dramatic movement across 2020. In East Asia, of course, here we are in Taiwan, and the bulk of the move in Taiwan from 0 to 30% happened in 2018. And again, there were some times around early May and in October where some providers moved almost overnight. Since then, in 2019, there has been further deployment, and 2020 was more about consolidation. But now almost half of the country's users are V6 capable in Taiwan, which is quite an achievement. Japan, which was a very, very early adopter, hasn't even got to half yet. While they've been doing this now for almost 10 years, it's been a very, very slow rate of progress. And while it's increasing every year, none of this is dramatic. So I'm not exactly sure why it's sort of so slow. It's consistent but slow. China is another, strange story in some respects. There's certainly some concern that it's not higher than this. Some folk in China actually believe they've done a full rollout already, and they may well have, but our numbers indicate that currently in China, around about 20% of users, which is a lot of users because there are many, many users in China, around 1 in 5 are V6 capable at the start of this year. And the bulk of that work happened across 2019. COVID certainly slowed things down in 2020. South Korea, SKA Telecom did work with 464 XLAT a long time ago, back in 2017, but since then, not much. And actually, it's one of the few countries it's going backwards. Australia, 2017 was sort of a noisy year. There was a lot of testing, and I think things were being turned off and on again. The service stabilised by 2020, and around 1/4 to 1/3 of users in Australia are now V6 capable. And similarly in New Zealand, around 28% or so, they did their move a little earlier. But again, the service is stabilising. So what can we say? Well, 2020 was not a big year for V6. In 2019, there was a 6% growth in users. Globally, it moved from 18% to 24%. But 2020, half that rate. And so the global percentages was from 24 to 27. But oddly enough, in Asia, it's still been moving. And across that 2 years, Sri Lanka, if I move down here, Malaysia, Taiwan, the net growth over those last 2 years has been 19% of users across that 2-year period. and Vietnam, 18% of users got turned on over that 2-year period. And similarly in this region, Thailand at 15%, Australia at 15.3 as well. That's the 2-year growth. We can actually look at the year before COVID and the year of COVID. India moved in 2019 up from 53 to 63, but then didn't move as much in 2020. So by the start of 2021, they were only 72%. So the biggest moves were in 2019, less so in 2020. Percentages of users, though, per country don't tell much. What we can do is actually look at what that means as people. The number of people that actually use V6 in each economy. And these numbers kind of get very interesting. And what we're looking at here is the number of users that were connected to V6 in that 24 months. India added a further 161 million users. China, 118 million users. Again, these are phenomenal numbers. In Vietnam, you turned on 10 million users over that 24-month period, which in absolute terms is a dramatically big achievement. And Taiwan, 7 million users over those 24 months. So it's pretty clear that of that 470 million users that got added, the bulk of them were in those two big economies, India and China. Big because they just have a lot of people. And so connecting them in actually means connecting a lot of people. And so if we look at annual growth rates, what you actually see is for 2019, the big move was in India, China, Mexico, Brazil, France, and Vietnam. But if you actually look at Vietnam, 7 million got connected in 2019, but a further 2 million got connected in 2020. So it might well have been that there were some impacts from COVID, lockdown, slowdown in deployment, because it was just a hard year. The same in Taiwan, that the bulk of the activity, 5 million new users in 2019 and 1.5 million new users in 2020. So it's pretty clear that COVID seems to have some kind of impact here on our deployment. And overall, it was about half of 2019. I was actually interested in this and I was trying to find out, was it at the start of the year or the end of the year? When did lockdown happen? When did the movement change? And so I was looking at month-by-month growth rates. And it's kind of interesting, across the summer period in the Northern Hemisphere, June, July, August, things slowed down. Whether it was COVID or things just slow down in summer, I don't know. But there was certainly a slowdown. But when you look at India, the bulk in the green line of the new connections was March, April, May, and then a large connections in October and November peaked, and then less in December. So there was kind of two phases in India. In China, the blue line, oddly enough, there was this massive shift near the end of the year in September. Huge number of users connected in a single month. Whereas at the start of the year, where I think they were deeply impacted by COVID, the activity was a lot smaller. And so there is some degree of monthly breakdown, and together with, I think, a break over summer across that year. Now, just in closing, to give us enough time for a few questions and other bits and pieces, let's just go back to this bigger picture again that I showed you at the start. And let's start thinking about where we're going. This is not where we're going. We are not trying to make the world dual stack. That's not it. We want to get rid of V4. What we want to do is get to the point where V6 is the only network protocol and that V4 isn't there anymore. And so the real question, I suppose, that all of us have to think about is, where are we? Well, if we fit these numbers in, we've got about 1/3 of the users on dual stack. And so we're about here in the you are here point in the big plan. But it's taken us 25 years to get there. And in some sense, we're following a trajectory that has been used by many other technologies. And whether it's mobile phones laptops, washing machines, air conditioners, all consumer technology follows a very similar path of adoption. The initial work is the enthusiasts, and we certainly saw V6 enthusiasts. Once the enthusiasts sort of do their job and say this is viable, you get the early adopters and the risk takers, the folk who generally jump early, who are willing to try something out. Because at any point in that early phase, it might fail. There's no guaranteed outcome at that point. At some point, though, there's what we call an inflection in adoption, where everyone else will get there. It's just a matter of time. And so up until that inflection point, failure is always an option. But once you reach that inflection point, the mainstream takes over, and then just the latecomers come in at the end. But it's an inevitable process. So whether we're talking air conditioners, mobile phones, or V6, very similar curve, because there are very similar pressures at play. Where are we in V6? Because it could be the case that now that we're up at 30%, it's just going to happen. Because if there was an inflection point, it would have occurred a couple of years ago. That was almost the last point where it might not have happened. And it's certainly true that one view is the world will go V6 at this point. It's just a matter of time. But that's only one view. There is another view that we're still yet to reach this inflection point. And you kind of go, why is that? If 30% of the users can do V6, surely it's not going to fail at this point. Surely this is where we're going. Now, this is not what you think it is. Because I don't think the alternative is V4 anymore. The V4 network's finished in terms of being able to address everything with a unique V4 address. That's over. And it was over by the time we started using NATs 20 years ago. But you kind of wonder if there are other networking technologies that we're going to move towards. Because what we're doing with V6 is the same we've done for the last 40 years. This is actually quite old technology. Destination-based packet forwarding networking architectures is the same as in the 70s and the 80s and the 90s, right? And all we did with V6 is make the addresses longer. We didn't change things. But oddly enough, if you look at what content data networks are doing and what so many folk are doing in terms of trying to make V4 addresses span bigger and bigger domains and get rid of address uniqueness, the network architecture we're actually using these days, oddly enough, is name-based. The name system, the DNS, is actually more important than addresses. And so we're actually able to make NATs work, even though they shouldn't, because we're doing so much more work at the application level using name-based architectures. And so when we look for the next 10 years and look beyond that, the real question is not V4 versus V6. That's a done deal, I suppose. It's V6 if that's where we're going. But the tension, I think, in network architecture is this next generation tension, the tension between destination-based packet forwarding and name-based architectures, which we're now just starting to get into. And the way we're doing with content-based networking, if you think about what we've done in the last year, almost the entire internet is content-based streaming. That's all we ever do these days. And content-based network architectures is what drives the internet. And that might well be the technology that we're looking at in the near to long-term future as an evolution from IPv4 or V6 or V anything else into a somewhat different architecture completely. It's worth thinking about. So that's the big picture. Thank you very much for your time, and I'll happily answer any questions that you might have. Thank you.
Thank you, Jeff. And the third speaker is Mr. Charles Liang. He is Department Manager at Taiwan Mobile. Charles is responsible for IP system design for mobile and fixed networks and core networks for mobile network. And he will present IPv6 deployment in the view of operator. Charles, please.
Okay. Good afternoon, ladies and gentlemen. I'm Charles Liang from Taiwan Mobile. It's an honor to receive ICANN APEC TWNIC's invite, and I'm here to present the current deployment of Taiwan Mobile's IPv6. Year 2000 is no ordinary year due to the COVID-19 pandemic. It seems like the world had paused in every way: economics, traveling, socializing, and so on. Let's say the Taiwanese government had been doing slow precaution in order to let the public work, study, travel the country without disturbance. And because of the country's hard work and devotion, the ICANN APEC TWNIC engagement forum can be successfully held in Taiwan via physical and online meeting today. On to the agenda for my presentation. First is the company profile of Taiwan Mobile. Taiwan Mobile was founded in February year 1997. In January year 1998, 2G mobile network started operating with a 0935 mobile number. In May year 2000, Taiwan fixed network was established and got the fixed network service license in year 2001. In May year 2005, Taiwan Mobile introduced the leading 3G services of the wideband CDMA system, and it's the start of 3G video era. In April year 2007, Taiwan Mobile merged Taiwan Fixed Network, a cable company, Taiwan Fixed Media, and Taiwan Telecommunication Network, and got the management right of these three companies. In June year 2014, Taiwan Mobile introduced 4G and started providing 4G services. In July year 2020, Taiwan Mobile launched 5G services for the open passport. In December year 2020, Taiwan Mobile deployed 6,000 5G base stations. That was the leading of all the operators in Taiwan. In March year 2021, Taiwan Mobile earned 6,000 5G subscribers. The corporate business service that Taiwan Mobile mainly offers are in the following three categories. The first one is mobile network services, mobile broadband internet, cloud games. Taiwan Mobile co-works with NVIDIA to provide the GeoForce Now games, and co-work with the Riot Games to provide the League of Legends series games. Momo e-commerce. Momo is a company that is 100% owned by Taiwan Mobile. Taiwan Mobile provide Momo the Fast Pass B2B2C service when 5G service launched last year. My series services, my video, my music, my book. Smart Stadium. The mother company of Taiwan Mobile is Fubon Group. Fubon owns two professional teams. One is the Fubon Guardian baseball team, and its home count is in New Taipei, Xinzhuang Baseball Stadium. The other one is Taipei Fubang Braves basketball team, and its home game is Taipei Heping Basketball Stadium. These two smart stadiums use the service of immersive virtual reality 360 live broadcast, 4K ultra high density video, and multi-view video streaming, 3D real-time replay, and the coming AR and MR services via multi-access edge computing technology and so on. The second one is TWM Broadband. It's a brand name of cable network services, cable broadband internet, cable digital TV, pay channel. Since some customers don't want to pay the whole cable monthly fee because they don't watch all of the channels, the customer can choose this pay-as-you-go service to select the specific channels they want. 5G plus Wi-Fi 6 bundle service is so-called 好数成双. It's a service that the customer can use 5G network service outdoor and Wi-Fi 6 with fiber at home. The customer just only need to pay a mobile monthly fee. The cable broadband internet with Wi-Fi 6 is for free, and home security and so on. The third one, TWM Solution, is the brand name of fixed enterprise services, fixed mobile broadband internet, mobile office, cloud PBX. The customer smartphones can be as an extended number of office PSTN lines, data center cloud service, cyber security, 5G enterprise private network, and so on. The usage rate of IPv6 as of March 2021, Taiwan had a rank number 7 in world's ranking with 51% usage rate. Taiwan Mobile's IPv6 usage rate had reached 72%. For your reference, the picture on the right is the growth chart of Taiwan Mobile's IPv6 usage rate. This is the current situation of Taiwan Mobile on IPv6 connection section and traffic throughput as of March 2021. IPv6 connection section had reached 3.6 million. IPv6 traffic throughput had reached 395 gigabits per second. Taiwan Mobile has co-worked with many global content delivery network companies. Take Facebook as an example. As of March 2021, the statistics showed that in year 2019, the utilization rate of IPv6 was 66%. In March 2021, the utilization rate of IPv6 has come to 87%. This is my final slide today about current challenge and future perspective. We came up with 3 conclusions. The first one is the upgrade from 4G to 5G. Because of the intensive competition among 5 telecom operators in Taiwan and the influence of 4G all-you-can-eat rate plan, the user of 4G have gradually saturated. Besides, 4G medium and low-end smartphones don't support IPv6. Only 5G smartphones support IPv6 and V4V6 dual stack. So it's a critical issue to every telecom operator to figure out how to upgrade their 4G users to 5G immediately. If this upgrade succeeds, the usage rate of IPv6 will increase. These are two phases of strategy that Taiwan Mobile will conduct. Phase one, we will encourage 4G medium and low-end smartphone users to upgrade to 5G when their contracts expire. However, if the user rejects this upgrade because of the price of 5G smartphone, we will advise this user to try a 4G high-end smartphone in a cheaper discounted price package. In this way, we can not only help some users upgrade to 5G, but also increase the usage rate of IPv6 from the support of IPv6 and V4 dual stack of 4G high-end smartphone. Phase two, when the price of 5G smartphone becomes more acceptable and agreeable, we can encourage the users to upgrade. At that time, not only the user can enjoy some higher speed and low latency internet service, the usage rate of IPv6 will increase as well. The second one is IoT device increase the usage rate of IPv6. Although there is already device for 4G, it faces two problems. The first one is because the design of IoT software did not consider the interworking with the network side. So it occasionally faces some overloading problem of massive signal registration. The second problem is because the cost of IoT device is cheap. When it leaves the factory, only the electrical character tests are considered. Therefore, without a complete wireless radio signaling strength, quality, and network access test of protocol signaling, it can trouble the telecom operators. 4G, most of the 4G IoT devices don't support IPv6 because of low-cost issue. The usage rate of IPv6 will increase significantly if 5G IoT device support IPv6 in the future. As for future prospect of these two problems, there are three service scenarios that 5G defines: enhanced mobile broadband, ultra-reliable low latency, and massive machine-type communication. Among them, massive machine-type communication, one of the service scenarios of 5G, is designed for IoT device. After the technique of 5G massive machine-type communication, going with narrow slicing becomes more mature. The problem of massive signal registration can be solved. About the second problem in the future, 5G IoT device will have the past experience of 4G. So we hope to strike a balance between costs and quality. Besides the electrical character tests, we will put more attention to the better design of signaling strength, quality, and protocol signaling for the wireless radio, also with a strict narrow access test from telecom operators. The usage rate of IPv6 will increase. And the second problem can be solved as well. The third one is B2B and B2B2C business expansion. Enhance mobile broadband. One of the service scenarios of 5G is the extension of 4G. The new ultra-reliable low-latency communication and massive machine-type communication belong to the business of B2B and B2B2C. In order to let 5G improve substantially, Taiwan Mobile will work its magic in mobile services to combine Momo's merit in e-commerce and integrate the resources of the company. At the same time, we will upgrade users' experience to boost the improvement for the usage rate of IPv6. This is my presentation for today. Thank you for your time. Thank you.
Thank you, Charles. Is there any question about the presentations for our speakers? I personally have a question for Mr. Jeff Houston. Do you believe or foresee the IPv4 will be eventually phased out? And when might it happen?
Thank you for that question. Do I believe that IPv4 will eventually be phased out, and when might that happen? And I suppose in some ways, I don't think it's ever going to go away. And part of the reason is we're still going to use it because it's implemented on billions and billions of end devices. But we used to use it as a globally significant addressed device. In other words, you can always reach me if my device has a v4 address. I don't think that's true today, and it certainly won't be true in the near future for almost any device. But v4 will be locally important because there's just so much of it around. And so in so many ways, I think local environments, closed environments like home environments, my car might still have v4 inside it for that kind of limited use. When you want to move into the larger networking domain, the question is, how are we going to do that? Now, right now, of course, when you use a mixture of v4 with NATs and increasingly v6, those are the options today. It's not clear where we go, but there are a few CDNs, content data networks, that I think are truly interesting. And the ones that are truly interesting use anycast addresses. So the way this kind of works is I go to some content from where I am in Australia, and I get an address for me and an address for the content that is locally in Australia. So address 1 talks to address 2. But when I go to Taipei and I go to the same content, I will get a different IP address from my NAT provider, and oddly enough, my content will have a different IP address, and the application will actually connect it up to the same content. And so addresses don't mean what they used to mean. They're not identity anymore. And what this means is that the world we're moving towards might not necessarily be a world that has global addressing anymore. We might not need to have it because we're actually building a client-server world, not a peer-to-peer world. And clients don't need addresses permanently. They just borrow an address, use it for a while, and send it back. And so that's the tension going on here. But if I was a network operator, I can't wait. I've got a problem today, not tomorrow, today. I haven't got enough v4 addresses. I've got lots and lots of clients. I'd like more. I want to do a 5G rollout. We've got no choice. We have to do v6 rollouts right here, right now. At the same time, the content folk need to understand that standing up content in v4 only is not acceptable. We have to move off v4 dependency because we just can't keep this working at the volume we're working at the cost we're working at, trying to keep NATs working in v6. So we're right that right now we're moving to v6. And I think that's sort of writing on the wall that's inevitable. But that's not the end point. It is really not the end point. The content folk are rewriting networking under our very eyes. And this whole issue with moving intelligence up into the application layer, moving transport from TCP to QUIC, actually says something quite fundamental about our network architecture, which is why I'm saying name-based architectures are the future for where we're going in 10 years' time. And so V6 is kind of what you've got to do today, absolutely. But it's not going to be the end goal. This is going to keep on moving, and we will be moving into more and more name-based with local addressing-based systems. So that's sort of my big vision anyway. Some others might disagree, but that's certainly where I see it at the moment. So thank you for the question.
Thank you, Jeff. Is there any question? If none, I would like to close this session. And we know IPv6 deployment plays an important role in the development of the internet. And this session brought us informative and forward-looking views about IPv6 deployment. And thank you for joining this session, and thank you our speakers, and this session is adjourned. Thank you.
Thank you very much, Mr. Ling, for moderating the session, and also thank you to all panelists for your very informative presentation. Thank you once again. Ladies and gentlemen, this concludes our first day forum. Thank you very much for your participation. We look forward to more fruitful discussions in the forum tomorrow. Thank you very much once again, and see you tomorrow.